inertia we were discussing in the last class. So if we have n number of masses are there and one axis is given, if n number of masses are given and an axis is given, and about this that axis moment of inertia will be m1 into r1 square, m2 into r2 square, m3 into r3 square. And if you will change this axis, then the moment of inertia will automatically change. So for the moment of inertia, the axis is important. Changing the axis change the moment of inertia. Okay, so we have completed this thing in the last class. So today we will solve the questions. So this is the question. In this question, this is a rectangle. This is not a rectangle, means these masses are placed at the corner of a rectangle having the width b and the length a. This is a by 2 and a by 2a. You have to find the moment of inertia about an axis passing through the center of mass like this. About this axis, you have to find the moment of inertia. So how we will find the moment of inertia? Okay, how we will find the moment of inertia? We can find the moment of inertia m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. But r should be the perpendicular distance from the axis of rotation. So this is the axis. This is the axis. So take the mass. For this mass, the moment of inertia. When you will calculate the total moment of inertia of this system, so it will be m. I am taking for this mass. I am just calculating the moment of inertia for this mass. And what will be r? This distance will be r. You will take this perpendicular distance. And what will be this distance? A by 2 square. A by 2 square. Now, for this mass, again, m into a by 2 square. For this mass, again, m into a by 2 square, because this will be the perpendicular distance. For this mass, m into perpendicular distance square, a by 2 square. So you can multiply it with by 4. Multiply it by 4. So you will get 4m a square divided by 4, and 4 cancel out. So you will get mass into a square, m into a square. This will be the answer. Okay, second question. These are the point masses. Okay, these are point masses, and these masses are placed at the vertices of a equilateral triangle. At the vertices of equilateral triangle, and this equilateral triangle has the length L given. This is the axis AB, AD. This axis is AD, and we have to find the moment of inertia. We have to find the moment of inertia of all these masses that are placed at the vertices of the equilateral triangle. Okay, these are just placed at the vertices of equilateral triangle. Okay, there is no such equilateral triangle here. Okay, so how we will find it? We know that moment of inertia is mass into perpendicular distance. Mass into perpendicular distance from the axis. So one by one. For this mass, you are calculating the moment of inertia about the axis AD. So for this mass, what will be the moment of inertia? Mass into what is distance? Distance is 0 because the axis is itself passing. So it is 0 square plus for this mass, it will be ml square because this is the perpendicular distance. This is the perpendicular distance. Okay. For this mass, now for this mass, what distance we will take? M perpendicular distance square. So perpendicular distance will be this. This will be perpendicular distance. So how we will find this perpendicular distance? See, if this is an equilateral triangle, so this angle must be 60 degree. If this angle is 60 degree, then this angle is also 60 degree. Alternate angles are equal. Okay, this line and this line parallel, so this angle is also 60 degree. And what is this length? This length is L. This length is L, and you want to find this distance. So you can take the component of this L. So it will be L cos 60. It will be L cos 60. Okay. And if you want to find this length, this will be L sin 60. And you can also apply the trigonometry. So M into L cos 60 square. And what is cos 60? 1 by 2. Cos 60 is 1 by 2. So we can find the moment of inertia about AD, that is equal to 0 plus ml square plus ml square multiplied by 1 by 4. Because here you will put 1 by 2 and square of that will be 1 by 4. So it is ml square by 4 plus ml square. So it will become 5 ml square by 4. 5 ml square divided by 4. Okay. So in this way you can calculate the moment of inertia of different masses placed at different positions. Here the positions are symmetric position and masses are different. Masses are just discrete masses. These are discrete masses. There will be the system that have the continuous mass. For example, I want to find the moment of inertia of this system. This have the continuous mass. So for that case, we will see what we will do. Write down this, please. Okay. So now we will discuss the moment of inertia for the continuous system. For the continuous system or continuous mass. So moment of inertia, MI means moment of inertia for continuous bodies. Continuous bodies means like cylinder you have, sphere, hmm? You have a rod, you have a ring, you have a disc. So I am just categorizing the bodies as one-dimensional bodies, two-dimensional bodies, and three-dimensional bodies. One-dimensional bodies have only length. Like rod, we consider rod as one-dimensional body. Two-dimensional body means there can be the area of rectangle type things. You can say a disc. A disc is a two-dimensional body. A disc is a two-dimensional body. It have the length also. It have a thickness also. And three-dimensional bodies like sphere, cube, cuboid. So first we will discuss for one-dimensional bodies. So we'll find the moment of inertia. First, we will find the moment of inertia of uniform rod. Okay, so how we will find, first discuss this. How we will find the moment of inertia for continuous bodies. For example, if you have a body like this and an axis is given to you, this is the axis given, and you want to find the moment of inertia of this body, this random body of irregular shape or regular shape, whatever you want to find moment of inertia. Earlier what you have discrete masses, then you are able to find m1 you have, and you have the perpendicular distance square plus m2 into r2 square. This thing you can do earlier in the earlier cases, but now this body is continuous body. So what you will do in this case, you will take a small elemental mass of this body, small elemental mass. Suppose we have chosen a small elemental mass dm. Dm means a very small elemental mass, and we will take the perpendicular distance of this mass. This will be the perpendicular distance. This is the r. Okay, for this mass, for this very small mass, very small mass or elemental mass, the moment of inertia is di. Di is the moment of inertia. Di means very small moment of inertia of this mass about this axis. That will be equal to dm. Dm is the mass into r square, and we will integrate. We will integrate both sides, because integration is just a summation that you cannot do. Okay, and di is the moment of inertia about this axis, and if you are able to do this differentiation dm into r square, then you can easily find the moment of inertia, and we will see how we can find that. So this is the one thing. Now practically how we will find with the help of this formula. For example, I want to find the moment of inertia of a uniform rod, of a uniform rod along axis passing through its center of mass, passing through its center of mass, and this have the mass m and have the length L. This rod have the mass m and length L. So one rod I am taking, and rod I am considering as a one-dimensional object. One-dimensional object. There will be only length in the rod. There will be no thickness we are assuming. So one-dimensional rod we are taking. So suppose this is a rod, very small, very negligible thickness rod we have, and we want to find the moment of inertia of this rod about an axis which is passing through the center of mass. These are, this is the axis and this is the rod, and this is the axis, and this axis is passing from the center of mass. So here is the center of mass. Okay, center of mass. This is the rod, and this rod has the length L. This rod has the length L and have the mass m. So now what we will do to calculate the moment of inertia about this axis? Suppose this axis you can take y axis. You want to find I of y of this rod, but this is a continuous mass. So what we will do? We will take a very small mass. Suppose we have taken very small length of this rod, dx length, and this dx length have the mass dm, and this is at a distance of x. This is at a distance of x from the axis of rotation. X is a perpendicular distance of this dx element of this rod, and whole length of the rod is L. Whole length of the rod is L. So what you will do? Small moment of inertia you will find for this mass dm, and that will be dm into x square. Dm into x square. Okay. But here is a problem. We cannot do the integration as such. We have to convert this dm in terms of x. Then we can do the integration. So as this is a one-dimensional object, for one-dimensional object there is a term lambda, mass per unit length. Mass per unit length. Lambda is, we have just defined one constant, and this lambda is constant. Lambda is mass per unit length. What is the meaning of lambda for this rod? Means in 1 meter length, there will be the mass lambda. Okay. Mass, lambda is the mass per unit length. So in 1 meter length, in unit length, this is the length here, and here is the mass. So here the mass is lambda. In 2 meter length, the mass will be 2 lambda. So what length we have? We have length dx. So in dx length, what will be the mass for the dx length? Can you tell me?
Dx lambda.
Very good. Dx into lambda. Dx into lambda. And this lambda is a constant quantity, and this lambda is basically mass of the rod divided by the length of the rod. So, okay. So what will be the value of this dm mass? This dm mass will be dx into lambda. For dx length, the mass is dm, and that is dx into lambda. So we can write, we can just integrate it both sides. We have to integrate both sides. So here we will get the moment of inertia about y axis, this axis, or you can just simply write the moment of inertia I. There is no requirement of this y and all that, because axis can change. We will change the axis also, but you have to remember the axis is passing through the center of mass and perpendicular to the rod. This you have to remember. Anyone can write xs or x, this x is as I x x. So in different books you will get different notation, but notation is not important. The concept is important. So now you can just put the value of dm. Dm is dx into lambda, dx into lambda, and here is x square. And now here is one of the most important thing. Now you are taking mass dm here. Okay, you are taking mass dm here. You can take mass dm here also. At this location also you can take the mass dm. At this location also you can take the mass dm. Can take the mass dm. So means throughout the length you can take the mass. Okay, but now here what you have to do now? Here what you have to do? Suppose this is the origin, and from this origin, this length, this corner will be covered. This corner will be covered means when you will go from here to here will be length L by 2. Here length will be minus L by 2. Means if you will cover this portion, L by 2, you can take the mass uh, up to limits. We are defining now limits. What are the limits of the integration? So it will be defining by L by 2 minus L by 2 to plus L by 2. Minus L by 2 to plus L by 2 can be the limit of the integration. So putting the limit is very important. How you will put, okay? So if you are going here in this direction, you have to take the negative limit. Here you will take the positive limit. So limit will be minus L by 2 to L by 2. Now I think you are in a condition to solve this easy uh, integration. This lambda I have told you is a constant quantity, so you can take this outside of integration. So here will be minus, limit is minus L by 2 to L by 2. So it will be capital L. Capital L by 2. So this is also capital L by 2. So limit means the extreme condition. Okay. So lambda is, we have taken outside of integration because it is constant. So we will have x square into dx. X square into dx. Now can you tell me what will be the integration of x square into dx? Okay. Please, if you know, then you can answer it, and otherwise you can write chat in the chat box. No, if you don't know. Okay. It means okay, very good. Okay. So if you don't know the integration, so if we do not know the integration, then we cannot solve this problem. So first, again, I am telling the integration. Okay, so suppose it is written that here is x and here is dx. Here is x, here is dx, and here is limit x1 and here is limit x2. So when you will integrate this x into dx, na, so here is x to the power 1. Here is x to the power 1. So you will write x square, and the power you are writing here, you will divide the same power in the denominator like this. And then you will apply the limits of integration x1 to x2. So you can take 1 by 2 out and you can apply the limit to x square. So half you have taken out. Now you can apply the limit x square, x1 to x2. So what is the meaning of applying the limit? We will do the upper limit minus lower limit. This is the upper limit. Upper limit. Do you have maths or any other subject in your 11th? Upper limit. Bio. Okay, no problem. That's fine. So if you have biology, no problem, that's fine. But at least I am not saying, because those students who have maths like me, I was in 12th, I have maths that time. So there na, in those students have math, they do not get problem in this, because this is the very easiest kind of integration we are doing here. So you have to just study this kind of integration, easiest kind of integration that will be used to study physics only. Okay, in detail you will not study that. Now you can just apply the limit. Half is there. How to apply the limit? Put the value of x2 in x square first. So it will become x2 square minus x1 square. This will be the answer. For example, uh, if it is written that minus L by 2 to L by 2, if it is written that minus L by 2 L by 2, and you have x square into dx. So what you will do here na, this is x square na, so here you will write x to the power 3 and you will divide it by 3 and you will apply the limits. Minus L by 2 is the lower limit, L by 2 is the upper limit. Any problem till here?
No, sir.
Okay. So now this 3 is a constant, so you can take out. So you can write 1 by 3. Now you can apply the limits. This is x cube and you can apply the limits minus L by 2 to L by 2. What is the meaning of applying the limit? Means you are putting first L by 2 in x, and after that you are subtracting and putting minus L by 2 in x cube. It means x. Okay. So what we will do here, it will be 1 by 3. Okay. So here you will put L by 2. Instead of x, you will put x L by 2, and there is a cube of L by x, so you will write L by 2 cube, and minus, there is a minus sign, and again you will put minus L by 2. You now, after that, this is the upper limit and this is the lower limit. You will put minus L by 2 cube, minus L by 2 cube of that. Are you getting it? This is the most complex thing, means for me to explain, because okay, got it now?
Yes, sir.
So now this is a simple calculation we can do easily. This is just the simple calculation. This is just the 10th class calculation. We can do it. It will be 1 by 3. And what is it will become? It will become L cube divided by 2 cube is 8. Now here is minus. And what it will become? It will become minus L cube divided by 8. Minus L cube divided by 8. So here you will get minus L cube divided by 8. So it is 1 by 3. And this is L cube divided by 8 and minus minus plus L cube divided by 8. Now it is very easy. 8 will be the LCM. 8 will be the LCM and here will be 2L cube. 2 4 is 8. So what you will get? 3L cube divided by 12. 3L cube divided by 12 you will get. So this was the integration. Okay, now here we have to solve this. So just now we have solved this. This value is 3L. This value will be 3L cube y 12, 3L cube by 12. So hmm, hmm. Okay. Hmm. Just a minute, just a minute. So we'll get the wrong answer. 1 by 12, it should be 1 by 12. So 3 multiple by 12. 3, okay, just a minute. Just check what is the mistake here. Please check.
Sir, it was just 1 by 12. Where is 3?
Sorry. I don't know why I have written this 3. L cube by 12. Okay. Okay, no problem. So we can write this integration. Just we have done this integration, x square dx minus L by 2 L by 2. X square dx minus L by 2 L by 2. So lambda we know, mass of the rod divided by the length of the rod, and this is L cube divided by 12. So L is cancel out and you will get L square. So finally the moment of inertia you will get ml square divided by 12. So the moment of inertia will be ml square divided by 12, and this moment of inertia is of the rod with respect to the axis passing from the center of mass and perpendicular to rod. In the last, I will write all the moment of inertias that we are going to calculate here. If suppose if you have the same rod, for example, the main thing now here to calculate the moment of inertia, but at the same time in your exam means I am not talking about the competitive exam. Just talking about the normal CBSE exam. So in CBSE exams, they will only ask you the simple moment of inertia calculation. And sometimes you have to learn also, you should know also what is the moment of inertia of a rod through an axis passing to the center of mass. Okay. If suppose, but I want to say that the main thing is to how to integrate. How to integrate is important here. If suppose they are asking the moment of inertia of an axis passing uh, at one end of the rod and perpendicular to the rod, if they are asking. So in that case, what we will do, right now we have not just studied the parallel axis theorem, so we cannot apply that. Suppose if we want to find it with the help of the integration. So just I am giving the idea what you will do. This is a rod of length L. Remember, this rod has the length L, and this rod has the mass m. So to solve the moment of inertia, you can take very small elemental mass, and this have the length ds. I am not saying the mass have the length dl. Means this element of the rod have length dx and have mass dm. And this distance is the perpendicular distance is x. you will assume. Now it is very easy. To find the moment of inertia, you have to do the integration integration of dm into x square. Now here the most important thing is to apply the limit, how you are applying the limit. For that you should choose one origin or reference point. Suppose this is the origin I am choosing, and you have to move along the rod like this for maximum to minimum to maximum. Minimum is 0, minimum of the rod is 0. What is the minimum value of the x? Actually x is the variable here. What is the minimum value of the x here? 0. What will be the maximum value of the x here? L. So you will apply the limit 0 to L. Here what we have done, x is the variable quantity here. So the here the minimum value of the x means x can go in the negative direction to the minimum or the minimum value of the length. We should not say the minimum value. We should say what is the extreme condition of x here will be minus L by 2. What will be the other extreme condition of x will be L by 2. But here you have to choose one origin point or reference point. So this is the origin point. So x can go, if you have chosen the origin, if x is going in the left direction, you will take the sign of the direction. In left, the x can go to the extreme or the limit minus L by 2. And to the right, it can go L by 2. Here, the minimum value of the x is 0 and maximum value is the L. Now, if you can solve this, you will get the moment of inertia, and you are going means you will get the moment of inertia. I think it will be ml square by 3. ml square by 3 you will get. Same thing you have to do. You have to replace this mass m. So how you will replace this mass m? So for you have to define lambda. Please, for unit mass, for unit length, the mass is lambda. For dx length, the mass will be dx into lambda. So dm is equal to dx into lambda. And okay, and what is lambda? Mass divided by length. So you will put the value here 0 to L. dm is dx into m by L. dx into m by L. And here is x square. Okay, so this can be converted 0 to L, and m by L you can take out of the integration because this is constant. You can write x square into dx. Again, you will do the integration, apply the limit, you will get ml square by 3. You will get ml square by 3. So the thing is, we have to apply the limit properly. We should know how to integrate. Okay, write down. So with practice, you will know how to apply the limits. Keep in mind, after the 11, definitely you will go in the 12, and definitely you will have the maths. So I want to give one advice that please learn the differentiation, please learn the integration properly. These two will be very, very important for you in future also, and in this class also, in 11th class. In 12th class, we will use integration again and again and differentiation again and again. There will be lots of derivation there, and without the integration we cannot solve those. So basics of integration at least. Hmm. Done. Okay. Completed.
Yes, sir.
Write down this integration, means how to do the integration. This is important. So after this, now we will calculate the moment of inertia of a ring. Okay. Holding down. Okay, complete this also. So just one thing I want to clear. Uh, from here, na, this thing we have just solved here, and finally we will get L cube by 12. That is why I have written here L cube by 12. Okay, so don't confuse. Okay. If you want to write this, then you can write it, otherwise no problem. Write it. Okay. So now we will calculate the moment of inertia of the ring. Moment of inertia of ring, but axis I will define from with respect to the axis which is perpendicular to the plane of the ring and passing through the center of mass. For example, this is a ring. For example, this is a ring. This is not a ring. Just imagine this is a ring. Ring is also we can consider a one dimension. Okay, because the mass is on the periphery of the ring. So here this is a ring and here is a ring. Just imagine here is a ring and there will be an axis like this, and that axis is passing through the center of mass of the ring and perpendicular to the plane of the ring. So you can just say that if you are taking three axes, you have, for example, so the ring is in this plane. This is the x-axis. This is x-axis. This is y-axis, or this is the z-axis. Take this as z-axis. This is z-axis and this is the y-axis. So don't say that this should be always y-axis. We can choose any axis according to the requirement. So if this is the ring. Now you can see here this ring in xy plane. This ring is in the xy plane, and they are saying find the moment of inertia of the ring from an axis which is passing through the center of mass of the ring, and perpendicular to the ring also. Okay, now it's fine. Center of the mass of the ring, and it will be like this. So this is the ring. And this ring is also a one dimensional. So now this axis is perpendicular. This ring is in xy plane. This ring is in xy plane. The ring is lying in xy plane, and this is the axis about which we want to find the moment of inertia. So you can write here the moment of inertia of the ring. Moment of inertia of a ring about an axis passing through this is the center of mass also. Okay, this is the center of mass, passing through center of mass and perpendicular to the plane of ring, Okay, so here what we will do, in this case, what we will do, this is the axis, and now all the mass of this ring is at the periphery, means here. So here we will take the small elemental mass. Here suppose we will take elemental mass here. This is the elemental mass dm I will take, and anywhere you will take the elemental mass. Suppose here you are taking the elemental mass dm. Always this distance, always this distance will remain same. That is r, capital R. This distance is not changing. Now, if you want to find the moment of inertia for the small mass, that will be dm into r square. Now, here is the condition that this r is the constant. R is the constant, so r square will also be the constant. So you can take r square out of the integration. You can take r square out of the integration, and here will be dm. And integration of dm means the total mass. So integration of dm means integration of dm means you are adding. Integration means the addition. Integration adds the things. So if you are taking dm so it means that you are adding dm throughout the length of this, okay, ring. So it will become r square. It will become r square into m. So integration here also you will do. So the moment of inertia I will be mr square. The moment of inertia I will be mr square. Okay, please write down. So in the next class, we will discuss how to calculate the moment of inertia of 2-dimensional and 3-dimensional bodies. And finally, I will give you all the values at one place. Means those values uh, you have to learn also, because when we will move in this chapter forward, then there will be the requirement of moment of inertia. Now all the game of this chapter will depend upon the moment of inertia. Like in the linear motion there is a mass, and here in rotational motion we have the moment of inertia. Okay, so if you want to ask any doubt, then you can ask me. And please attend the class on time, and please don't miss the classes.